And the rest of the guys over here as well. Nice. All right, so with liar's dice done, we're going to close down all the liar's dice items. We don't need that open anymore. So let's close those all down, shrink those down, and bring back open our bank tools, and account items. And so the last thing we started building was this account interface. This is what we started building on it. Account interface system, because we noticed that our debit card and our client really benefited from having a list of accounts instead of a list of instead of separate lists for each and every account. Without some sort of way to connect all these items, bank account, CD investment, checking account, investment account, savings account, in order for our client to have multiple of these items, of all of these, we would have to have a separate list for each and every type. We'd then have to have either a different add method for each and every type, with overload for each one, which can be very, very not dynamic. You know, we've always talked about that acronym, DRY. Anyone remember what DRY means?
Don't repeat. Right?
Yeah,
Don't repeat.
Don't repeat your.
Don't repeat yourself. Yep.
Yourself.
We want dry code. We want our code to be dry. We don't want to repeat ourselves. And so we saw that we were repeating ourselves. We were creating multiple lists for every single account type. We would then have to create multiple add accounts for each and every account type. So we changed it up by making this account interface. Account interfaces, again, just a TLDR of it, is kind of like an agreement or contract. This is you telling this class here that this item, whatever is put in here, is an account, and an account will have the following public items: a withdrawal method and a deposit method. Anything else is not guaranteed. We could have other items, but an account is guaranteed to have these methods. That's what an interface allows us to do. It gives that guarantee that these items will do it. And so all we have to do is now make sure that every single one of our accounts has these two methods. Now we do know that all of these accounts, CD, checking, investment, and savings, do have these because they're all inherited from the bank account class. So they all do get it, but we did make sure to implement it so that we know that every single one of these implements without having to go back up and check parent accounts. So we know that every single one of these implements the account interface. So if we go back to our debit card now, what we can do is update our charge method. Well, actually, we don't need to anymore because we already see how it did that. So we can see in the charge method that we can withdraw from our primary account, even though the primary account, oh no, it is a checking account. Never mind, that didn't work right. Kill these, actually. Let's clean this up a little bit. We didn't need those again. We said that. We didn't need these anymore. I think there was a challenge I think I gave you guys here last minute of being able to actually can add the, oh no, it was on the client, right? So in here, yeah, add debit card. This is what we were challenged with, but if you guys checking out what we can do with this, we can just display them all if we wanted to as well. So there's that as well. We can display them all, but that doesn't really show how we're able to utilize that withdraw and deposit method, but we'll get to those later on. That's not a big deal at the moment, so it's okay. Ooh, I remember how I can show it. If I head back to, don't need, now that's there. List account, ATM accounts. Do we need to show that yet? No, let's keep going actually. Let's go back to here. So that's fine. I am using the withdraw method somewhere. Where am I using the withdraw method in the account? Unless I'm overriding it. It's possible I might be doing that actually. Never mind. I'm gonna go first. So looking through this again, just to make sure we understand what's happening. We have our client, which has the name, social security number, address, first name, last name. We bring all that information in, and we have an ability to add an account to our client. That's fine. But we now want to be able to add a debit card to our client. We want to be able to add the debit card to the client. Oh, that's what I want to do actually. Here we go. To show how the account interface works first, actually, before we do the debit card, I do want to show how the account interface works. If you go to an ATM, you can access, or if you go to the teller, you can access any account on your as a client, right? And withdraw from them or deposit more money into that account, right? you're allowed to do that. And so what we can do is public void withdraw. And for now, what we're going to do is we're going to actually ask for the account we want to withdraw from just for the moment, just so you can see it. What eventually we're going to do is actually get a identifier for the account so then we can actually search and pull it in, because we may not have access to the whole class, but like we did here in the debit card, the account now. So you know what, actually? We may actually build this first because this will help with this one. Yeah, let's do that. So you don't want to actually access the full account. So let's hold on this one first. Let's go through here and figure out how we can do this little challenge here. Otherwise, we'll have to do the same thing. So the account num, we have a list of accounts that we need to find an account number in. Now we talked about how we can't do, and we do know how arrays have array.index of, right? We know how we can do that. If I go back to main now for a second, where's my main for banks? Here we go. Right here? Yeah, here we go. Let's clear some of this out. Clear that out too. If I create an array, int array equals array. Oh no, wait, let's do this right. Like that. So I can do that, create an array of numbers 1 through 4. We know that my array, that's not the right one. My array dot, don't we have index of? Contains.
No, regular arrays only have length.
Really?
Yeah.
No index of in Java, huh?
Nothing. They suck.
It did. All right, well, let's switch this to a list then. Now we can do that. So let's go back to now list. We can do array list. I knew that there's a method arrays.toList. Oh, what's the command again? What's that method? What package is it under? I know the package. It's a toList from array. Java.
Arrays.toList.
Arrays.toList. It's a plural, right?
Yeah.
To as list. It's literally right there, the very first thing that pops up. Of course. As list. All right. And new. Oh, right. That's what I need to do. New.
Listen.
Thank you. All right. Here's the list. Oh no, I remember now. There we go. Right? No.
You have to change it from int to integer. It doesn't let you do it as a primitive type.
Right. You're right. I can't do primitives. I have to do actual lists have to contain objects. Thank you. I totally blanked on that. Yep. Lists cannot contain primitives. They have to contain the object class. So you have to use integer, not int, and like float with a capital F instead of float with a small f. So you have to use the class instance of the object of the item of the primitive. So thank you on that. There we go. Arrays as list 1, 2, 3, 4. There we go. That's it. Again, this is one of those things that's easy to forget because it's just like arrays instead of array, as list instead of to list, and then don't use the curly bracket syntax. Actually, I think you can do that now. So I think now I can do new integer
array or integer array, yeah.
Like this, and then do the curly brackets, and that should be accepted now too. So yep,
Yeah.
Okay. I knew I've done it like this before. So I was like, I know I've done it this way. So there we go. That's it. And again, just to clarify, that is something that you could always, if that happens in an interview, you'll usually have a computer on you, be like, look, I know I can do this. I can't remember the exact syntax. If I look it up, and they'll most likely say, yeah, that's fine. It's unlikely you'll need to do this during the interview, but these kind of things, like knowing what you can do, but having a brain fart on the syntax is not going to be a killer, as long as it doesn't happen so often that it slows down your solution. That's what you want to be wary of. Anyway, so now the list, I think that does have index of. Yes, so list has index of. Do myArray.index of, and if I do a 3, so we have that, and we hit play, we'll see that that kind of gives us what we want. Oh, right, I'll switch probably back to the normal main. My bad. Switch back to normal main, because now we're going to play liar's dice again. We don't want to do that. We get the number 2, which is, of course, the index 3. The index of 3 is 2, so that's correct. If I try to find the number that doesn't exist, we see we get the -1. Now that looks like something we might be able to use in our system, right? We can send the account number and do, we might be able to do accounts.index of, right? We might be able to do that. Well, let's test that first before we actually think about it, because index of is finding an array of simple elements, nothing complicated. These aren't objects really. They're simple items with just one value. They have a single value. So objects are a little more complicated. So let's actually do this now. Let's do, what's our car class? Maybe we'll use that quick just because it might be smaller and simpler. Yeah, we'll use that. Yeah, we'll use our car class for a quick second, just because that's going to be quick and easy to use. I got to stop doing that and do the split vertically. There we go. Just to see if this works. So list car equals my cars equals list. We'll do new. We'll do my cars, or my cars. Add new car. All right. What do we want to give it? Anybody have a car they liked? What color is our car?
Blue.
Blue car. What's the model of the car?
Subaru.
Subaru. What's your car's VIN?
123.
Yeah. Now we can just do the year for this. We don't have to worry about tire count. What's our year for this one?
2008.
Really old. And that's 208. That's a really old car. Also, we did that as an int. There we go. I'm also going to hide this for a second. We can have more screen size. There we go. My cars dot add. Someone else, what's your car that you want? Give me a dream car of yours. What color is your dream car? Who wants to go next?
It's not a dream car, but I like my car.
Go for it then. That's actually a good thing. Being happy with the car you currently have is good. What color is the car?
White.
All right. What's the model?
Toyota.
Fake VIN.
321.
I like it. And what year is it?
2003.
All right. And what if I do right my cars? It's yelling at me. We'll do one more. My cars dot add new car. Will or Richie, which one do you want to give me your dream car or your current car?
Silver.
Model?
Nissan.
What's your fake VIN?
567.
7. I like it. And what year is the car?
2018.
18. There we go. All right. Very good. And so now I want to check this to see if we can do an index of. Well, we wanted to see, you know what? I know that our VIN is going to be technically our unique identifier in our cars, right? That's what VINs are supposed to be. They're supposed to be the unique identifier. And so can we search for our car by VIN by doing our index of? Well, let's see. You can do my cars, index of, and I'll give it 1, 2, 3. Let's see what happens. You know that that car exists. Huh. Gives us a -1. Huh. That didn't work right. I do my array again and look at this dot index of. It does take an object O and returns an int. So it requires the same item as my cars dot index of. Yeah. Both take an object, but yet this one's not giving me what I want, is it? Let me show you why. So index of, if I give it a new car, white, Toyota, 1, 3. So I say index of a new car with the color white, Toyota 321 in 2003. So I mimicked this exact item. I created the exact same object. If I hit play now, it still says no. Didn't think so. Wasn't sure. I thought that might work. White Toyota 321 2003. So no. Now here's what I can do instead. I think this should work. That. Cut, paste. If I spell it right, I can't get that second L for some reason. There you go. If I do index of, save, play. Oh, when did I lose? Oh, I didn't semicolon there. All right, play, try that again. You will see now it does see the item. So index of looks for a perfect match. It doesn't look for partial matches, and there's no way for us to tell it to do a partial match. We can't tell index of to say, hey, search this array of indexes of objects, check this field and see if this field matches this item. We can't do that with index of. Index of requires an exact match, even to the sense that it has to be the exact same object. As you saw, I created a second car with the exact same data, white Toyota 321 2003. I created the exact same car, but even that didn't trigger because, again, the memory address isn't matched. There's still hidden data that we can't see that's inherited from the object class that isn't matching. And so it still doesn't check it. So this isn't going to work for us. Using index of is not something we can use for our client class to find the account number. So that's not going to work. Because what we could do is we could loop through we could just iterate through our list until we find the one we want and then return that, right? We can then say, oh, I found the item, let's return that index. So we could loop through it one by one until we find it. We could do that, right? Is that correct? We could do that, but that could get really slow, right?
Mm.
That if there's a client with a lot of accounts, that could be really slow. Not very likely in this example, but it's something you want to think about. Always think about what your process would do if you suddenly were to multiply it by 100 or multiply it by 1,000. Would that process still be efficient, or is it going to be slower? Well, is there anything else we can use that we know we can jump straight to an item? Is there a collection that allows us to kind of like access something directly by a identifier?
A hash map?
Yeah, like a hash map, like a dictionary, right? Hash map, what we used to call dictionaries, but yeah, I gotta stop saying that because yeah, in Java, it is officially hash map now. Dictionaries are obsolete, right? Sorry, in C# you still have both dictionaries and hash maps, and they are technically considered different. So anyway, yeah, hash map is just that key value pair, kind of like JSON objects, right? Very similar to that, where we could create this item where you have an object, and then you have an ID number, and then inside is an object. And so we could change this from a list to private hash map. What's our count number? Is that an integer or a string? Let's double check. So in the bank account class, the debit card, so account number in our bank account, our account num is a string. So we just keep that a string. Okay, cool. So you can do hash map string count. So this thing is that our key will be a string. Our identifier is the string, and the value or the content of that string is an account. Do new hash map. And again, because of how it works, we don't necessarily need that content there. You can put it there if you want, but it's not needed. I just like to show that. So new hash map. We do need to update our add account method. Our add account method no longer has add. We now have dot set. Key set? No. Dot put. That was it, right? Key account stop put. We'll give it account dot account num, which, oh, look at that. We can't get the account num, can we? No, we don't have any way to get the account number, do we? From our account class. Did our checking account have that? Oh, sorry, our bank account? Did our bank account have the ability to get the account number? No, look, we didn't. We had no way to get our account number, so we probably need to add that, right? Let's add that here. So we'll do a get here. So let's do public string account num return account num. Beautiful. Back to our client now. We'll move that over here so it's closer. All right, so now account dot. I still don't have it. I just added it, didn't I? We added it to bank account. It's there. Why is it not here?
Is bank account? No, it is.
It's an account.
It's implements account.
But does our account system guarantee that every single item that implements it will have a get account num?
Oh no, because it's not.
This is where that trick comes into play. This is where the understanding comes into play. So account only guarantees withdraw and deposit. Technically, another object could implement account and not provide this method. It doesn't have to provide this method. So it cannot guarantee to our client system that this method exists in all implementations. It's only guaranteeing withdraw and deposit and anything else that comes from the object class. That's when we see the account dot, we can see all these other items that we don't know what they are because they are from the object class. But the only ones we see are that we recognize is deposit, withdraw, and toString. These are the ones we know we have on a regular basis. So we need to add to our interface string get account num, and that's now going to allow us. Be aware that in here we still again don't need the override command here. We can put it if we want to. Again, this is one of the things we are allowed to do. The benefit that this can provide is to verify that this is actually overriding this item correctly. If I was to misspell this by doing account num with an N, it's going to tell me, hey, there's no parent class or interface that you're overriding. So that's what's useful about this field. It's not a required little annotation, but this annotation can help to catch misspellings, incorrect items, or a method that doesn't actually exist in either a parent class or a interface. So it can help you to realize you made a mistake. So that's why those can be very useful to have. So account num, we are now overriding this empty account num with the implementation that we want here. That's all that does. Nothing too fancy. But now with that there, if I hit the dot now, we can see our get account num actually exists now. Now we have access to it. So we can do that. So the put, I can hit Command P again, we'll see we got the key, and now we need to put the actual account. So we'll go ahead and do account. So what this does, this creates a nice one-to-one connection. That if we create an account, it's going to be account num : account. So this will give us a way to jump to an item directly. Currently have a string display accounts. Let's add a second one now that does, oh, right. We have to update this. Forgot about that. For each account and accounts, which we can no longer do because we can't do a for in with a list. what windows for that one again? There is a way to do it. Oh, right. So we can do is accounts dot key set. What this does is gives us each key, so one string at a time. And now what I can do is do accounts dot get. Oh, right. Not get. Is it get? No.
You want the account to just print out. Wouldn't you just do instead of key set do values? Because the account is the value, isn't it?
Could also do that. Yeah.
Yeah.
I forgot about that one. Good call. That's what I meant to do. Yep. Dot values. Forgot that they have that one. Yep. Now we'll get each account one by one. Good call. The key set though does give you each key one by one, so then you can then also just do accounts dot get and then give it the key number, and then the key, the account, and then it'll print it out too. Anyway, this actually does look better. I like this one better. Good call. So we got that. That fixes that. Now we can do the next one. So let's go ahead and see public string display account singular. And this is going to take a string account num. We want to print or display that single account based on the account number. And so what we're going to do here is do s out accounts dot get and that should get us the account. And then of course that already has a toString method. We don't necessarily have to call toString. Even though I did it here, you don't have to actually call toString. Oh, I don't want to do a system.println. I forgot. I want to do return. Dot toString. There we go. That's what I want to do. That'll give us the string, so we can display a single account. Let's see this work. As long as this makes sense and works, we will see it, and we'll be able to actually see if this works. And can we add a couple accounts and get one by one. So let's head back to main now. Move that closer so we can see it better. Back to main. No longer need the cars anymore. Let's get rid of those. Let's do, we need to create a bank. We need to create a couple bank accounts. So let's go ahead and do, we'll do a checking account. Checking account. And P, oop, not that button. P, we'll give it 1,000. Mine. I'm also going to close this out now because I don't need to see any more of that. Account num 2, 3, 4. Folks, we need a daily limit, huh? All right. We'll do 500. Also add a savings account. Equals new savings account. Command P again to see what we need. We need a balance. I'll put 3,000 in the savings account. I'll let my wife have this one. Call it 5543, and we'll give it a interest of 5. All right, and I will do client equals new client. All right, 555 and 1 chestnut. That works. I'm going to do cliff.add account, checking account. I'll then do cliff.add account, savings, save those. And now we actually want to do an S out first of all my accounts. So let's do cliff.display accounts first so we can see all of them. We'll then do an S out just to print an empty line, and then we'll do S out checking. Oh no, savings first. I don't want to jump to the middle. Savings. S out dot display accounts. And I could, of course, do savings dot account num, but I'm actually just going to take this string right here, copy and paste. Display account. There we go. So display that one account. So let's see if that works. So we see here we get the 2 accounts. And then we'll see down here we get that 1 account. Nice and simple. Let me show how that works a little better. I'm actually going to take this. I'm going to cut it. Put that there now. Take this. Cut. Paste. Add that extra that extra parenthesis there. So you see it again, do the same thing. So you know that that main has no access to these created items. There's no reference to these inside of main. We only can access them through the client system. Because we have that account number, we can access it nice and easily through just having that account number without having to iterate through our list. We don't have to iterate through all of our accounts. We can jump straight to the account we want as long as we have that key. So we have the key, we're good for it. So this is the main point that I'm trying to bring up here is that idea of understanding how the use cases of each of these items. What are the benefits? We know array lists, they have an order to them. So that's one of the things I do want to keep very much in mind. Array lists have an order that is very much set in stone. They're very much set from this one to this one to this one. Lists don't really have an order. You can't really sort them. They can appear to have an order at first, like we saw here. But at any time, I can remove and add new ones, and that order may not behave the way you might think it would. So if I was to remove, let's say, the savings account, if I was to add a second one, then remove the savings account, then add a third one, there's no guarantee that that order, and as I keep adding and removing items, that order is going to stay consistent. So that's one thing you do want to keep in the back of your mind. There's no consistency in ordering in hash tables or in hash maps. They can be adjusted based on where things are in memory. So do be aware of that. There's no guarantee that the order you're expecting in a hash map will be the way they come out. Whereas arrays, their order is very much set in stone, and they're very much set up in a certain way to keep that order, to maintain that order. Excuse me. All right, so we have that. Let's go ahead and do a add debit card, account num list of accounts. We need to find the account. We need to find the account and save it to the account variable, and then display the account details to the console. What is dinging? Everything good? Okay, cool. Anyway, fine, I'll check that later. Good. Anyway, so let's do the withdraw account now. Withdraw account, instead of getting the account, we'll now get the account number instead, so you can withdraw from the account. First thing we need to do is find the account. Find the account. We know how to do that because we did that right here in the display system. How did we find the account? Remember how we do that. How do we get the account? So account equals accounts. And then what's my method I want to use? What method will pull the account based on the account number? Get, right? Yeah. You get, we can give it the account num. I don't know why I did that with a capital A. That's wrong. Let's do that. Num. Now that I can do account. Oh, I should also say how much. Int amount. There we go. And ooh, we should probably return that. No. What does our withdraw method do, by the way? Does the withdraw method return? It does not. Okay, it just does the void. Okay, we don't need to return. So account withdraw amount. Return. Let's see if this allows us to do it. So we're going to go back to main. So we displayed all the accounts this time. So we're going to display them all. We displayed the savings. Let's withdraw from our savings account, print it again. So let's do withdraw account 5543. And we're going to withdraw 745. We'll do that. We'll S out the account name again, display accounts, 5543. Let's also withdraw from our savings, our checking account too. Withdraw account. That one was the, let's see, 1, 2, 3, 4. That one we'll go ahead and withdraw 387. There we go. S out. Display account. 5543. Let's see what this does. Print. Oop. Wait, I just printed out the same as account again. Dang it. Do that again. Try that again. All right. So we have our savings at our checkings at 100. Our savings at 3,000. We see it again. We then withdrew from the savings account. We can see it withdrew. We then withdrew from the checking account, which we see it did. So know how we can now use the same withdraw account method on both the checking and the savings account, because again, an account is guaranteed to have a withdraw method, right? If I remember correctly though, wasn't there something a little extra? Does this math add up? I think it does actually. Wasn't there something special with this checking account's withdraw method? Nope, there wasn't. Okay, we didn't actually do anything special with the savings account. It was probably the investment or the other account that had the specialty on it. Anyway, all good. Yeah, we can see how it did the withdraw method on both items. Which one had the specialty one? Now I don't want to see it though. It's the investment account that applied a fee. Yeah, see the investment account applied a fee. Let's add that quick, just so we can see that it does do that withdraw method. Quick. Not add account, new investment account. Let's give ourselves 10,000 investment. Why is it not doing it? Weird. And Vietnam 7. The investment, we'll do 8, and that's good. Down here, we'll do a cliff.withdraw amount account. We'll do the 9987. We'll withdraw 100, but because of our fee system, it should withdraw 1100. And then we'll do, instead of doing the display accounts, we'll do this time is we'll just display all of them. This out, display accounts. There we go. We'll do this. All right. See what that does. All right. So 1,000, 10,000. Okay. And here's actually, so good. I wanted to see this. I'm glad it did this. So remember how I said there's no guaranteed order? Look at that. We have the checking account first, the savings account second, and the investment account third, right? But look how it printed it. See how the order changed? So that was what I was trying to point out. Hash maps do not have a guaranteed order. It looks like it might be trying to order them maybe by our type, checking, investment, savings maybe, but there's no guarantee, and we're just noticing a pattern because as humans, we're designed to detect patterns. We want to see patterns. So
Yeah, I wonder if it's alphabetically.
yeah, I'm wondering by this, even though, how does it know that? Because again, we mapped them by the account num. So you would think that these would probably be in order, wouldn't they? So again, it's one of those items where it's like, is that it? I don't know. It's hard to tell what the actual trick is, what's actually happening. Why that order went like that. Right now, the current pattern we see is this, but if I added 3 or 4 more accounts, would that maintain the same without testing it? But there's no way to know for sure. But that's why I want to say, don't bank on a hash maps order. Or you can trust an array lists order, an arrays order, but you can't trust the hash maps order. Anyway, we got that, but now let's look down and see. So we took out the 745, what is it, 387, so that looks correct. 387 was taken out of there. We took out of the savings account 745, which looks like, but look over here, we took out 100, but we actually lost 1100. So you can see that we did use the investment account's withdrawal method that added on a $1,000 fee or 1,000 unit fee to our withdrawal on the investment account. So we see that it does work like that. So even though I'm not specifying, I'm still using account.withdraw because investment account implements account, we utilize investment account's withdrawal method. So that's what interfaces allow us to do. Treat all these classes the same, group them together, but still utilize that class. still use the investment account class, still use the checking account class, even though they, in our client system, they're all accounts. So there's the power of a interface. That's one power of them.
Huh.
Sound good so far? Good there. So let's now challenge us with the debit card system. We want to go ahead and bring in create a debit card. So same thing here. We get the account number. We want to find the account so we can then save it for later. So let's go ahead and do that again. Primary, sorry. Account for the debit card, and that's going to be accounts dot, we already know, get account num. I did the capital A again for some reason. Why do I do that? So let's try creating a debit card now. So new debit card. What do we need for this? We need the card number. You want to give me a card number for this one? Or do we just want to use our same little tricks we've been using? Maybe card number elite. Our PIN, 5555. Security code, 032. Card owner currently is a string, so we're going to go ahead and give it this dot name, or just name. And our checking account primary, which is our primary account. Oh, but it's yelling at us. Why? Let's see what it wants. Why is this unhappy?
Because it wants a checking account. You gotta typecast it.
Yeah, right. We have an account. We need to change this though. So we need to change it to. We simply do a typecast, which is a parenthesis in front of it with the data type we want it to become. Checking account. That. Why? What the hell happened there?
You have to import it.
Would have. Why do you keep scrolling down? Stop that. That is weird. Huh. Import.
Back to the manual ways of things.
Yeah, I don't know why it's not doing the auto import, but whatever. We'll do it. Not sure why the auto import's not working, but whatever. So we do that. And that will typecast this here. Any problems we see here?
Your account might not be a checking account that gets passed in.
And is there any
Might then throw
guarantee
an
that the
error.
account number that the person types in will actually be a checking account? No, there's no guarantee, right? Like as I said before, though, when you're first coding something, it is okay to assume you're going to get correct data in the beginning. It is okay to do that. It is okay to assume that we're always going to get the checking account because during our debug phase, we are entering the data. So we know we're going to be correct. We're going to put the right stuff in to make sure it works. So it's okay for now to assume we're going to get checking account, but being aware that there's no guarantee of that is nice, and adding that to do verify the account is a checking account. It's something we definitely want to add. Now, does anyone know how you would determine what type this account is?
I always like when doing classes for instance of.
Yeah, there's that instance of, right? So using instance of. I'm still going to leave this out because I want you guys to kind of practice. So instance of. That's something you guys can add later. I'm going to keep my code like this so you can, there's things in here that you can add on. Again, there's improvements you can do to make this better. So we have our card. Let's go ahead and do cards or debit cards dot add our card. And there we go. We should have a card hopefully. So let's save it. Let's go back to main now. We see that we do have our display accounts will display debit cards if we have any. Let's add a card. Let that add debit card. And add the checking account, which was number 1, 2, 3, 4. Save, we'll hit play. Didn't display, why not? Oh, dumb. Yeah, we're still on there. There we go. There we go. Well, kind of. We aren't really displaying the actual card, but we are getting a debit card. There is an actual instance of a debit card there. So this is that, again, this is what happens if you don't actually have, this is the default behavior of toString. So if you don't define something, some way to display it, it defaults to showing you a memory address. So it says this item is a banktools.debit card and it's located in memory at this location. If anyone's wondering what that means, that's what that means. But it tells us that we do have a debit card there. If we go back to our client class, we can take a look. We do card.toString, but if you look at our card class, we don't have a toString method here. There's no toString method. We have a details class. That's what it is. So let's head back to our client and change from toString to details. Let's change that. Glad I noticed that. Void type not allowed here, what? I only guess we just printed, we didn't actually, yep, we did. So details, we did a system.out. We want to change this, so we can change this to instead of print line, we can just do a return. That should do it. Let's see. There we go. We now have a debit card attached to our system and we can print it correctly. So this is our first item of the client system that will work. Why is it yelling at me right now? It's not. Okay. So there we go. We have an ability to withdraw accounts. We can add accounts. We can add a debit card. The next thing we're going to do is we're actually going to create a bank system next. So next thing we're going to actually add a bank class. And here's a mini challenge for you. So new Java class. I'm going to do for Thursday. I'm going to create a bank class. So it's going to need a, what are a couple fields that we want to do for a bank class?
Name, maybe?
Yeah, name of the bank. That makes sense. Yep. Name. I like it. What else do we have? Some attributes of a bank. Will or Richie or Christian, anyone of you guys got something? You think of a bank and you had to talk about what data does a bank contain. What could you give me?
Vault, safe, how much money they got.
I guess, yeah, I guess you could do bank balance if you really wanted to.
Yeah,
How much money do they have on hand?
on hand? Yeah, like in bank currently here.
And cash. Do that. What else is there? I want something from everyone here. Richard and Will, what do you got?
Location.
Location? Yeah, we can do that. We can do a street address again like we did in the client name. So street. No, because this one I want to do something a little easier. Let's just do city. Make my life a little easier so I have to always try to type out a street name. I can just type out a city. Will, what do you got for me? You got a bank. What do you think? Give me an attribute. With me?
Cliff, you capitalized the C in city.
Thank you. Any ideas, Will?
Oh, I said location. I said city.
That was you? Oh, I thought that was Richard because his box lit up. Richard, what do you got for me? Unless you go take care of the dog. I see a chat. Hold on. There's a chat there.
Clients?
Clients? Well, yeah, that's kind of the thing we're going to be doing next, right? So yeah, we have the list. Clients. Right? We have that nice client class, and all banks have a clients to each bank. That look good, right? So with that being said, now again, Are these data types perfect? Are they all the data types you might want to have? No, you might come up with more. So here's your challenges. What are the actions that a bank is going to be able to do? Well, first, we want to be able to create the bank. That's going to be our constructor. What are some of the actions a bank can do? Add a client, right? What else do we want to be able to do?
Display clients.
Display clients. We definitely want to do that. What else? Do. So I want to clarify something then, quick. When we add an account, we don't create the account on the client. We accept an account from somewhere. So if we had to think about it, who's in charge of creating accounts?
The bank.
Yeah, the bank creates the accounts, right? Yeah, so create account. And it's possible we may also, maybe, list of accounts. We may want that, maybe. That even though we know that the client has a list of the accounts, we may also want the bank to have a list of the accounts too. So they know all the accounts they have. Maybe. You can think about. But yeah, create the account. What else are they going to be able to do?
It's gonna have to add the account to a client.
Yeah, they can add the account. They can add the account to client. Yep. Maybe they'll do that while they create the account, or that could be a secondary method that the create account calls after it creates it. Some options. Definitely a bunch of different ways to build this. That's why it's going to be a nice little mini challenge for you guys to come up with, to see what you come up with. Is there anything else that they can do? Or does that seem like a good start?
But close an account.
I like it. Close account. Cool. So that's what I'm going to leave you guys with. If you want, of course, if you come up with more and add more, that's awesome. The more you do, the better the practice. Definitely want to practice these things. So let's go ahead and do git add -a, git commit -m.
Thank you.
And no problem. I know I hate when I forget to do this at the end of class.
Yeah, I know. It's like,
I have to take like some blame on myself. It's like, oh, I gotta remember to do that. So client
Well,
done.
I'm so happy you do it because Gabe wasn't really doing it when we were learning like Node and whatnot.
It's nice to have these. Like, that's why I like the videos. It's good to have the videos. It's good to have the actual code so you can refer to it. Like I said, a lot of times, the main thing is if you ever use the code, I tend to prefer using it as a code along where I can see it, but you definitely want to not copy paste from my code if you're ever using it, but use it as like a guide. So that would be my biggest recommendation on that. You want to avoid as often as you can copy and pasting from other code. Always type it so you get that muscle memory from what you use. So very, very rarely do I ever copy paste something from the internet into my code. I tend to find it and then type out what they give so I can tweak it as I go and still just kind of learn about it and make sure I understand all the lines. So my recommendation, yeah, there it goes. Push that there. So take this down, bring it down, give it a shot, or even just, honestly, you could just, well, if you have your own variation of the kind of coding along with me, build it in your own. That way you can, of course, follow along with us. If you do decide to build it on what you've built with me, make sure to make a branch out of it so you can always switch back to the main branch, then follow along and see what we actually end up creating in a class. So on Thursday. Yeah, I think that's it. Awesome there. I'm going to go through everyone's liar's dice. So I'll be going through those tonight and tomorrow, see how that went. And then, yeah, we'll keep going forward on this. And we are going to build at least one more interface. So understand, I'm going to say something very simple here. In this main class, there's a couple things you're going to run into that can be made better. It's not a big deal right now, so don't worry about it at the moment. You'll be able 100% be able to build this without the other things that I'm thinking of. But there's going to be a better way that we want to do it for anyone who's thinking of a hacker level item when creating account. Allow either random account number generation or keyed account number generator. That's one of the things you want to think about. So in the beginning, there's this idea that we can either have the teller actually key in the account number for the new account, or it can be randomly generated, right? It can also be done number by number, but there's multiple ways we can do this, and that's something we might want to think about. How are we going to do that stuff? So that's going to be that's what we're going to do later. This is something you can actually kind of think about if you want to challenge yourself to think if you can come up with another interface, but I don't think that'll happen. We're going to see how that works on Thursday, and we're going to create a second interface that's going to allow us to kind of jump back and forth between different systems to really see another really, and the more common use case of the interface that might make us a little bit more sense. So with that being said, I'm going to leave this with you guys there. I'm not going to push this line here to GitHub because that's not important. That's not something you have to do. Just come up with the best bank account you can come up with, bank class that you can come up with. So really try to play with this. This is for you to kind of, again, practice your Java, play around with it, see what you can come up with, and really feel free to go above and beyond if you want to. But anyway, I'll see everyone on Thursday. Sound good?
Later.
Take it easy. Bye, everyone. Well.